So this video is going to be a more practical and direct approach to how to identify intervals in the wild. So when we see them in music, or when we are asked to just name intervals or play an interval, sing an interval, identify an interval, we're going to need to really familiarize ourselves not just with what we learned before, the size and quality, but also we're going to need specific techniques. In this video, I'll present 4, which will guarantee us different ways of arriving at intervals and of checking our work, of making sure that we've generated the correct interval every time. So that's going to be this video, just identifying these 6 intervals with their size and quality. But I'm also going to show you as we go 4 methods that we want to use to approach specifically the quality question. So let's start with size though, because size, as we learned in the previous videos, is easier. Let's take this one from F to F. And so we recognize these notes. Now here's going to be for every interval we encounter. Step 1 is going to be identify the size of the interval by counting the letter names or the lines and spaces. We've already kind of seen this before. All we have to do is count on our fingers or on the lines and spaces on the staff the distance between F to F, including F. So let's go on our fingers. F, G, A, B, C, D, E, F. Just using the letter names in our fingers, we get 8. Let's see how that goes on the keyboard. 1, 2, 3, 4, 5, 6, 7, 8. Now the notes themselves don't matter here. All we're doing here is just counting up all the letter names, each white note in other words. And we get the size, which is simply 8. Okay, but as we discussed before, this is not enough to tell us, is this a perfect octave? Couldn't it also be an augmented octave, a diminished octave? Couldn't there be some change? How do we know for sure this is a perfect octave? Perfect, again, being the quality. So step 1 was get the size. Pretty straightforward. Just count it on your fingers, count the letter names, count the lines and spaces. Step 2 is get the quality of the interval. And in order to do this, this is where our 4 techniques are really going to come into play. So technique number 1 is the mechanical way. Let's try this. This is just going to be basically counting half steps. We know how to just count half steps. Half steps being the relationship between each note. So if I pull up the keyboard, we can see, counting half steps from F to F. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. Just as we expect, we've got from F to F, 12 half steps. In fact, this is a perfect octave because perfect octave has 12 half steps. In other words, all of the half steps between the octaves. So this is a gimme. F to F is a perfect octave, and that equals 12 half steps. So when we're using the mechanical way, these are going to be the really important reference points to remember. The octave is 12. Half of the octave is the tritone. That's 6. So we learned about this in the previous video, but just to show you again, the octave here from C to C, if I split it directly in half, I get this. 6 half steps. And 6 half steps going down as well to C. So the tritone, or the augmented fourth, or the diminished fifth, all different names for the same interval, is exactly halfway, is exactly 6. And as we've seen, the perfect fifth is 1 half step bigger than the tritone, which is 7 half steps then. And the perfect fourth is 1 half step smaller than the tritone, so that one is 5 half steps. And you can see I've listed those important landmarks there. Perfect octave is 12 half steps, perfect fifth is 7 half steps, and the perfect fourth, which is 5 half steps. So that one was pretty straightforward. Let's try a different one in a similar way. Now again, we're going to start with step 1, get the size. So the size of this interval from A up to D, we can either use our fingers, we can use the piano. So on the piano that looks like this, 1, 2, 3, 4. A, B, C, D. Okay, so 4. This interval, the size, is 4. This is, in other words, some kind of fourth. A to D is some kind of fourth. Which kind of fourth? Again, fourth is one of these intervals like the octave and the fifth, which could be perfect, or it could be stretched, could be augmented, or it could be squished, could be diminished. The fourth, we already can eliminate major and minor, just like with the octave. We weren't worried about, is this a major octave, is this a minor octave? Because the perfect octave is just always the perfect octave, unless it's F to F sharp or something like that. Same with A to D, actually, the perfect fourth is always going to be a perfect fourth unless it's stretched in some way. But before we can be sure, we need to have some way of verifying this is a perfect fourth. When we're looking for the quality, we can use again this mechanical method. And as we saw before, one of our important intervals to remember was the perfect fourth, and it has 5 half steps. So now we know 5 half steps has to be how many are contained between A and D in order for it to be a perfect fourth. Well, if we just look at the piano again, we can count out those half steps using the mechanical way. 1, 2, 3, 4, 5. So A to D is a perfect fourth, with 5 half steps in it. Perfect fourth. So that was the mechanical way of identifying intervals. And like I said, I'm going to show you 4 techniques, and they're not mutually exclusive. In other words, they all mutually reinforce. In fact, you'll want to use a little bit of each one. Find out the one that works best for you, the one that you remember best, the one that's quickest for you. And then that'll be the one you'll use most of all. And eventually, you'll come to a point where these are basically memorized, and you will be easily recognizing intervals very quickly. So let me show you way number 2. This I'm going to call the scales way. We can identify some intervals based on the scales that they fit into. Do they fit in the major scale, or do they fit in the minor scale? And interestingly about the major scale pattern and the minor scale pattern is that, especially with thirds, sixths, and sevenths, we can tell are they major or minor based on the scale that they are contained in. Let me spell that out a little clearer. Here, let's just take C major. From C to C in C major, perfect unison. From C to D, major second. From C to E, major third. From C to F, perfect fourth. From C to G, perfect fifth. From C to A, major sixth. And from C to B, major seventh, before going back to C, which is the octave. So there's a cool pattern here, right? Everything you see is either perfect or major in C major, coming up from the bottom note of C major. Now it has to always, this is example you can see in the lines, that emanating out from the bottom note. So C to D, C up to E, C up to F. That only works if the bottom note there is the root note of C major. But what you can do then is, if you are presented with an interval, make the bottom note the root note of a major scale, and then double check. So I'm looking at a third. Well, if it fits into the major scale that I would build on that root note, then it would be a major third. If it fits into the major scale, say I'm looking at a sixth, C to A, and I'm not sure, well, I build a C major scale. Sure enough, C to A fits in the C major scale, so that's a major sixth. And same with major seventh, and same with major third. So 3, 6, and 7 especially. Now, I say not necessarily seconds. This method works best for thirds, sixths, and sevenths. Let me show you why. Because if we use also then minor, we remember that the relationship between the parallel major and the parallel minor, in other words, minor keys and major keys that have the same starting and ending note, they have different notes though, because the relationship we know is that the third scale degree goes down by half step, the sixth scale degree goes down by half step, and the seventh scale degree goes down by half step. So third, sixths, and sevenths from major to minor become from major to minor. Let's look at the minor scale. So then that's going to be a minor third from C to E flat. That's going to be a minor sixth from C to A flat, and a minor seventh from C to B flat. You can use the minor scale to identify, okay, this third, sixth, and seventh, is this a major third, sixth, or seventh, or a minor third, sixth, or seventh? That doesn't work for the major second, because both scales have major second between C and D. The minor scale has minor seconds elsewhere, we know, because the minor scale has half steps elsewhere. So does the major scale have half steps. So with major and minor seconds, these are just whole steps and half steps, not a reliable method. The scales way, we just have to be able to count, okay, is this a half step or is this a whole step, in order to figure out our seconds. But this does work well for thirds, sixths, and sevenths. Let's use an example. Fourth, let's take the first one. So this one we have A and C. Let's figure out the size. That's step 1. So A to C is pretty straightforward. That's a third. 1, 2, 3, right? A, B, C. So that's how we count the size, just counting the letter names up. We recognize that this is a third, some kind of third. But now with thirds, we need to know, is this major third? Is this minor third? It could also be an augmented third or a diminished third. In this case, we're mostly going to start by worrying, is this major or minor? And if it's not either of those, then it might be an augmented third or a diminished third. But if we want to use the scales way to figure out, is this a major third or a minor third, we can do that. Let's use the scale way to get the quality here. So On the keyboard that looks like this. Let's try the major scale first, see if that works, and then if we have trouble, we can try the minor scale. And one of those will probably fit, because it's probably going to be either a major third or a minor third, based on the fact that there's no accidentals there, making it bigger or smaller than it is. It's just the white notes, so it's probably either major or minor third. In this case, if I put the major scale pattern of whole steps and half steps, whole, whole, half, whole, 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 half, and I'm looking to get from A to C, I'm looking to see if that A to C would fit in the major scale, coming up from A. Right, again, I just put the bottom note of the interval as my root note and check the interval. Well, that doesn't work. So if you look closely, if you go 2 whole steps in a row, A to B is a whole step, but then B to, well, we're skipping over C, we're going to C sharp. That's the other whole step. So actually, this already tells us this is not a major third. You see why? Because if this interval fit into the major scale coming up from A, then it would be a major third. But since it's not fitting into the major scale, we might think, this must be a minor third. Let's check with the minor scale. Whole, half at the beginning. So between A and B is still a whole step, but between B and C is just a half step. There we go. Now we've got our interval and we've fit it into the minor scale. And what that tells us is that this is a minor third. In other words, we can write it just M3, lowercase m for minor, and a third. So that's the scales way, and actually that's a pretty good way, especially, as I say, for thirds, sixths, and sevenths. The pattern way is the third way I want to talk about. And this is more general. It works actually for size and quality. This is just to do with like things that will sit in the background of our memory, just like in the mechanical way, and help us to organize the intervals more quickly. Let me just give you some examples of the pattern way. These are some patterns of notation, and then I want you to be able to relate these to the keyboard. So let me just show you. The top one shows seconds, right? The second from C to D, the second from D to E, the second from E to F. They're all kinds of seconds. They're not unisons. They're neighboring notes. In other words, whole steps and half steps, or for our interval language, major and minor seconds. But notice the pattern. They all look the same, right? They're all just notes that are right next to each other. So all the seconds will always look like seconds, whether they're major or minor, or augmented or diminished. They'll always be neighboring letter names. Same with the fifths. So the fifths will always look like fifths. Take a look from C to C. Sorry, the first one from C to G, the second one from D to A, the third one from E to B. They all look like the same distance apart. They all look like fifths. Same even for the last one, B to F. It looks like a fifth. This one, of course, is a diminished fifth actually, but it still looks on the page like a fifth. So for size especially, we can immediately recognize any of these would be fifths. The quality does depend on our either being able to count the half steps or our memorizing of these patterns. And the same goes for the fourth. So the fourth will always be looking like a fourth from C to F, from D to G, etc. And the fifths, they kind of go from line to line, skipping a line, or from space to space, skipping a space every time. And for the fourths, they go from line to space or from space to line, skipping, well, you can see the pattern there, just one shorter than a fifth, and so on. That's the basics of patterns in our notation. And I think if we apply this to one of them, we can see also how they work with quality. So for example, for step one, for the size, let's take this one, B to C. This one's pretty straightforward. The size we can recognize immediately. We were just looking at them. The size is a second, some kind of second. But is this a major second or a minor second? Maybe if we're not memorized yet, it might not be immediately apparent. But this one, for the quality, we can just look back at the patterns. So we should memorize that from C to D is a whole step, from D to E is a whole step, but from E to F is a half step. And why is that? Well, just remember on the keyboard. C to D, whole step, with a black note in between. D to E, whole step, black note in between. But E to F is a half step. And same with B and C. So those two are, when I talk about patterns in notation, you can see, but also patterns on the keyboard, just remembering that between E and F is a half step and between B and C is a half step. So that without any sharps or flats, you can see on the notation there that every time, unless we're dealing with E, F, B, and C, we'll have a whole step. But with those two, we'll have a half step. Then if you look with the fifths, it's the same kind of pattern. It's all the white notes, no sharps or flats there. And all of them are perfect fifths except B to F. And the reason is the same. Perfect fifth, perfect fifth, perfect fifth, perfect fifth, perfect fifth, perfect fifth, diminished fifth. So you can also notice the difference in the quality. Perfect fifth, tritone. Here's a perfect fifth. Here's a tritone. So every time I get to B and F, I lose the quality of perfect. Suddenly it's too few half steps, right? Between C and G is 7 half steps. But between B and F is only 6 half steps. It's just a tritone. And the reason is because, look, there's only 2 black notes in between here. But every other fifth has 3 black notes in there. Until I'm at B and F again, and then it's just 2. So that's why the pattern of the perfect fifths is the way it is, because, and why the notation they all look the same as fifths. But if we remember the keyboard pattern, then we recognize that not all of them are perfect, some of them are diminished, or just the one is diminished without sharps and flats. And then same with the seconds, where between E and F we have a half step, and between B and C we have a half step. So hopefully you can see why this is relevant to the interval we were just looking at, right? Because the interval we were just looking at was B to C, and that is in fact, without any sharps or flats there, that is a half step, or in other words, a minor second. So the correct answer for size and quality on this one would be minor second. Okay, so that was the patterns way, and that's a very general, and will come with practice. But it's good to have in the back of your head too, like pay attention to those patterns. That will help you. Try not to forget those, especially the keyboard and the way it's laid out. So the fourth one and the last one I'll talk about today is the inversion method. And inverting intervals will become really important for us when we start talking about harmony, because inversion is just a matter of rearranging the same notes. Just like rotation, or the term I was using when we have a scale or a set collection of pitches and we start and end on different notes but using the same collection of pitches. Inversion is similar because we keep the same 2 notes of the interval and we just change the order in which they appear. Let me give an example. So here we've seen this before. This is just our C major scale with C running at the bottom. So the first one on the top is CC, then CD, then CE, then CF, then CG. Okay, so we've got our unison, our second, our third, our fourth, our fifth. And because it's C major, we know exactly the quality too. That's first one's going to be perfect unison, then a major second, then a major third, then a perfect fourth, perfect fifth, then a major sixth, major seventh, then a perfect octave. We know that top line, but we actually haven't really explored what it would look like upside down. In other words, what would happen if we invert these intervals? So the bottom line is the inversion. What I say for inversion is to invert an interval, either move the bottom note, you have 2 notes, either move the bottom note up an octave or move the top note down an octave. And you'll result with the same thing, which is just flipping the interval upside down and creating a new interval. It's inversional pair. So these come in inversional pairs because there's only 2 notes. You can only rearrange it one way. So vertically, you can see the rearrangements. Let me show this. On the bottom staff, all of the C's have been moved up an octave, right? So instead of being middle C the whole time, which you see on the top staff, on the bottom staff, now they're the octave above middle C, and that C hangs there the whole time. So that's why these are all inversions, because the bottom C has been moved up an octave. But all of them vertically are the same pair of notes. C and C, D and C, E and C, F and C, G and C. Okay, so it's either C and G or G and C. You can see, or it's either A and C, A to C, or C to A. And they're going to be different intervals, but they're going to have a relationship. They share stuff in common. They're inversions of one another. They're inversional pairs. Like I said, we know that top line. We can identify those pretty easily. We've seen it a few times. What are the bottom line intervals? What are their inversional pairs? Well, we know the first one, right? The bottom line, the first one's an octave. So we can see that the perfect unison inverts to the octave. From C up to D is a major second, you see on the top line, but from D up to C is, well, some kind of seventh, right? Because it's one less than the octave. So octave, then seventh, then sixth, then fifth, then fourth and third, then second, then unison, because it's just going backwards. So that second inverts to a seventh. That third inverts to a sixth. In fact, I'll just fill these in for you. The top one is a perfect unison, which inverts to a perfect octave. Major second inverts to a minor seventh. Major third inverts to a minor sixth. Perfect fourth inverts to a perfect fifth. Perfect fifth inverts to a perfect fourth. Major sixth inverts to a minor third. Major seventh inverts to a minor second. And perfect octave inverts to a perfect unison. I hope you're already starting to see the pattern, but it will take a little bit further explanation before we can actually make this a useful method of figuring stuff out. Just to reinforce that, these show the connection. The blue line is the C's, so this middle C that has gone up an octave on each one, and the white lines show the moving note, in other words, the F, the G, the A, the B, just so you can make it extra clear where those are. And as I say, these are all inversional pairs with another. And you can see that they kind of, it sort of runs this way and then gets to the middle at fifth and fourth, flips, and then runs this way. Let's explore the pattern. What do we notice about the relationship of these? Well, something that's really important to recognize is that all of the interval size inversions, now we're just talking about size here, all of them will add up to 9. So we can see that so clearly, right? Unison plus octave, 9. Second plus seventh, 9. Third plus sixth, 9. Fourth plus fifth, 9. Fifth plus fourth is 9, etc. So all of them will add up to 9 vertically. If I just show that on the keyboard, we can see if I take second and seventh, major second from C to D, and a minor seventh from D to C, that splits the octave at D and creates, like I said, a major second and a minor seventh. And those sizes, the second and the seventh, will sum to 9. Same thing if I split here. Perfect fourth, perfect fifth, sums to 9. Here, and here, perfect fifth and perfect fourth, sum to 9. Okay, so that will work every time. That will work every time. And you can always figure out the size of a big interval, if you're not exactly sure, by quickly flipping it, making it a small interval, and going backward. Let me show you that in a little bit clearer way. Well, so that was the first rule. All the inversion sizes will sum to 9. Then what about quality? Can inversion tell us about quality? Well, yes. And actually, this is where it's the most helpful. So when we look at this chart again, and we kind of pay attention to the qualities, let's focus in on the perfect ones. Notice that a perfect unison inverts to a perfect octave. And a perfect fourth, perfect fifth, perfect fourth, perfect. So each time you see a perfect interval, its inversional pair is also perfect automatically. So every time, and this is where the inversion way is super helpful with quality, because each time you have a perfect interval, it's going to stay perfect. What about major and minor? And augmented and diminished, for example. We don't have any of those here, but it still works that way. Major and minor, we notice that a major second becomes a minor seventh, and that a major third becomes a minor sixth. So the sizes are still summing to 9 every time, but now we notice that the qualities are also inverting. They're flipping. Qualities flip, except perfect, which stays perfect. So that's the second rule. Intervals, when they invert, their size inversions sum to 9, and their qualities flip to their opposite, including augmented and diminished, but not including perfect, which stays perfect. And we saw that when the unison inverts to the perfect octave, and the fifth inverts to the fourth. So the perfect intervals are kind of off in their own world. They, even under inversion, stay perfect. Okay, let's take a few more examples using the inversion method, and that'll close the video for today. So let's finish up the 2 that we haven't gotten to yet. And these are actually also the 2 that have sharps and flats, and the 2 most complicated on this little list of intervals we were given to identify. Step 1, to get the size, we don't need to use inversion really, because this is a pretty reliable method. We can still just count on the keyboard D, E, F, G, A, B, C. Even though we're counting from D flat, with size it doesn't matter. It's just the letter names. Still count from D as 1. D sharp is a kind of, it should say D flat, but D flat is a kind of D there. So 1, 2, 3, 4, 5, 6, 7. We still get from D to C as 7. Some kind of 7. We're dealing with some kind of 7th here. But we don't yet know what kind of 7th. Is this a major 7th? Is this a minor 7th? We could use the scales way. That would work for 7ths, right? We know, we learned earlier that if we just make the bottom note D flat into, we could put a D flat major scale down and see if C natural fits into D flat major scale, in which case it would be a major 7th. And if it doesn't, if it only works in D minor scale, in a D flat minor scale, then it would be a minor seventh. But the problem with the scale way here is then I have to build a D flat major scale. And that will take way longer than if I can just sort of figure out this interval much more quickly somehow. And counting half steps with this seventh, I mean, I'll be counting 11 or 10 half steps. 12 half steps will get me an octave. This is clearly not an octave. So it's going to be one of the sevenths, either a major seventh or a minor seventh. It's 10 or 11 half steps. So that's too much work. It's going to take too long. What's a quicker way? Inversion. Inversion gives us the quickest way to the quality of this interval. So if we invert this interval, all we have to do is take the bottom note, D flat, and move it up an octave. So it goes from being a big interval to suddenly becoming a much, much smaller interval, and one that becomes way easier to read. This seventh now becomes a second, some kind of second, either major second or minor second. We still don't know the quality. This does help us though, because now that we have some kind of second there, it's so much quicker to count the number of half steps. We can basically use the inversion way combined with the mechanical way, because if we make a big interval into a small interval, the mechanical way is no problem. We just remember from the keyboard actually that C and D flat are right next door to each other. That's one half step. In other words, a minor second. So we've got a minor second for C to D flat. That's great. But we're not done. So we can't stop there. We have to then invert this back to the major seventh in order to get the correct answer for the size and quality of the interval we were originally asked. Second inverts to seventh. So we're already good on the size. We know it's going to be some kind of seventh, but what kind of seventh? Well, minor for minor second will flip to major. As we saw with the rules of inversion is that interval qualities flip to their opposite. In this case, minor will flip to major. So that answers so quickly, we have a major seventh here. Compared to counting the half steps, compared to doing even the scale way, inversion is the quickest way to get big intervals, especially because you can quickly make them into small intervals and then flip them back using the easy rules, summing to 9 for size and then flipping the quality. So then we've got this one. One that looked really challenging is suddenly clear to us. It's a major seventh. And we can double check on the keyboard that one, because another thing to think about here is with a seventh, we're one short of the octave. Here's the octave from C to C, but D flat is right here. So think about it, that interval must be 11 half steps. It must be a major seventh if it's just one half step above C there. And inversion showed us that same thing when we went. Okay, so I hope you can see there on the keyboard how there's many ways to think about these different intervals, especially bigger intervals. They can be kind of intimidating if they have sharps and flats and whatever, but it's easier when we use inversion and when we use common sense, like this is just one short of the octave. Or here, this octave from D flat to D flat. There we go. Interesting sounding interval, right? The major seventh. Kind of cool. Okay, last one. We're almost done. Here we go. Here's the last one. Now this last one's the most difficult. Not for the size. The size is easy for all of them, but quality-wise, this one's going to take the most finagling. Let's use the inversion method one more time and see if we can, because this is a pretty big interval. Notice that with small intervals, inverting them actually makes it harder, because then you have a big interval to deal with. You want to get intervals small so they're easy to count, then invert them back to their big size. With this one, we can easily count the size, as I said. The size is just 1, 2, 3, 4, 5, 6, up from F to D. So counting on the keyboard, you can see there. Now, we're still counting to D, like in the last example, because D sharp is a kind of D. So we're counting 1, 2, 3, 4, 5, 6 to D. It's some kind of sixth from F to D. Now, one thing that's helpful with these sometimes with sharps and flats when you see them is to take them off for a second and just think, okay, what kind of sixth would this be if it were from F to D natural? Like if there were no sharp or flat there. And then we could maybe use the scale method or something to tell, is this a major sixth or a minor sixth? Like we remember that F major has B flat, but that's it. It only has B flat, so the other notes are the white notes. And that we see from F to D natural would be a major sixth, but this is F to D sharp. It's even bigger even bigger than a major sixth. So that's one way, and I recommend using this kind of comparative method. When you see with sharps and flats there, a lot of times I'll just kind of ignore the sharps and flats for a second, say, what would this interval be if it were just the white notes? And then I'll put the sharp back on and remind myself, oh yeah, now it's being stretched or it's being compressed. In which case, if it's being compressed even further than minor, even smaller than minor, we remember this would be called diminished. And in this case, where it's being expanded even bigger than major, that would be augmented. Okay, so we've got an educated guess. Let's put it that way. We've made an educated guess that this is an augmented sixth. Let's take a closer look. Maybe we can figure out with inversion that this is definitely an augmented sixth. So we have no problem there. Well, if we invert it, just like we did with the last one, we know that the size will become from a sixth, it'll become a third. It was F to D sharp, now it's D sharp to F. And if we look closer at the quality of these, we'll want to measure the quality of the small interval, get that, which will be easier, and then flip it to double check the sixth. When it comes to the interval from D sharp to F, we can look on the keyboard there. It's a little small, but you can see D sharp to F, and you can see there's only 2 half steps there. D sharp to E is 1 half step, and then E to F is 1 half step. So 2 half steps, but that's just a whole step. 2 half steps, we learned that's a major second. Are we done? Do we invert the major second? We get a minor seventh. Is that what this interval? Unfortunately, while that's right in terms of how it's sounding, like E flat to F, or F to E flat, F, in other words, F to D sharp, it's sounding like a major second, but it is written as some kind of third. It's written as D sharp to F. So even though it only has 2 half steps, it's not a major second. This is actually a third. Is it a minor third? Well, no, there's no way, because a minor third has 3 half steps. In this case, it's 2 half steps. It's smaller than a minor third. This is a diminished third. You can also figure that out because if you ignore the sharp, and then you know that D to F is a minor third, you can figure that out with the scales way or with counting the half steps. D sharp to F is compressed from a minor third. It's now a diminished third. And as we guessed before, diminished third inverts to augmented sixth because the qualities flip. So actually this just verified for us what we already found out using a kind of comparative mechanical way. So that covers the augmented sixth and all the intervals that we had here. Remember that the first one we found was a minor third. We used the scales way to find that. The second one was the augmented sixth. We just did that with inversion way, but we also kind of used a comparative way. Comparing major sixth, what would be a major sixth is now being stretched. The major seventh, well, we said the scales way was going to take too long, so we used inversion and we got it like that. The perfect octave, that was the first one, straightforward. The minor second, that one we use the pattern way. We should remember that the pattern is that between E and F, no black note, half step. And between B and C, no black note, half step. And then with the last one was the perfect fourth. And we found that basically mechanically by counting the half steps and memorizing that perfect octave is 12 half steps, perfect fifth is 7 half steps, and perfect fourth is 5 half steps. So those were the 4 ways I can think of to quickly identify intervals. And as I said at the beginning, you're going to use some combination of these ways. Maybe let me know which way works the best for you, or if you have an additional way that's helpful for you, or something else that you've figured out, some way of memorizing the patterns of the intervals and ways that help you quickly identify what they are. Let me know.